You checking the first one?
Yeah, I want to see what you got with the first one. That determines if I did it right.
So the period is 2 pi divided by the number in front of x, and so that'd be pi over 2.
So when it's like, when it's just an x, what would you make that period? Would it be 1?
Yeah, if there's no number in front telling you that the period is, or if it's just an x, then it's 2 pi divided by 1 or just 2 pi. Right?
Oh,
yeah, so this time I didn't divide it by anything because I knew that dividing it by 1 would keep it the same. If there's no number written in the front, then the amplitude is 1. That's like the default amplitude. Yeah, number 7, you're going to have 2 pi over a fraction, right? And you're going to do keep it, change it, flip it. So with your marker, all we want to do is we're going to take these curves and we are going to trace the curve for just one full period of the graph. So I'm starting right here, and that is one full period of the graph because it did the whole shape. It went up, it came down, it went up again, and it stopped. Okay? If I was to trace it again, it would do the exact same shape again, and that would be 2 periods of the graph. I just want one. Okay? All right, now this problem, the pi is written over here, but it's just that the teacher, I did not make this worksheet, but the teacher who made this worksheet had a little bit of trouble with the computer formatting. So if you look, this is supposed to be 2 pi right here at the end. So that means that this right here should be pi. That right there should be where the pi is. If we're distributing everything kind of evenly. I think the rest of the graphs are relatively okay, but that one was a little bit off. So if we look at this graph, the period of the graph is how long it takes to go through that full range of motion. So how long did it take? Yeah, 0 to pi would be pi. And then the amplitude is how far up or how far down you go from the center. So the center of the graph is right here. It goes up 3, it goes down 3, so the amplitude is 3. Does that make sense?
So then all of these have to go up and down.
Mm-hmm. Well, the nice thing, these ones, none of these have a vertical shift. They haven't. So I talked in the video about the midline. Did I talk about the midline?
Yeah.
So if on these particular graphs, the midline happens to be the x-axis, right there, there's the middle. So you could just look at how far up and down it goes from that. But if the graph had been shifted up, then you'd have to be a little bit more careful. Or if it had been shifted down. Okay. So this graph, cosine and sine curves actually look exactly the same. They're just a shifted version. They shift left and right from each other. So this graph, I would say it's like a sine graph because it has the shape where it started at 0 and went up and down. Or if I wanted to be a cosine graph, then it would have had to be shifted to the left or right to make it a cosine. Okay? So this primarily, I would probably write a sine equation for it if I had to. Okay? All right, for number 11. This one starts at the top. So I'm going to trace it down and trace it to where it goes back to the top. Okay? So this graph looks a little bit more like a cosine graph. Like the original equation to me would be a cosine graph. I could write a sine equation for it, but if I wrote a sine equation for it, I would have to say that it shifted to the left. Or I could say that it shifted to the right. Okay? But if I'm going to talk about it starting at the y-axis, then the way that it starts at the y-axis makes it look like a cosine graph. Does that make sense? I can always write 2 different types of equations for it, but there's one equation that I could write based on it starting at the y-axis. Okay? So this one to me appears to be a cosine graph if I was to start at the y-axis. The period of this graph is what? Goes down, comes back up, again, and it stops at 2 pi. So it does the whole shape of the graph from 0 to 2 pi. And then after that, it does the whole shape of the graph again. So it goes down, comes back up to 4 pi. would go down, come back up to 6 pi. Go down, come back up to 8 pi. Okay. What's the amplitude of this graph? 4. All right, so the next one. This one has a period of 4 pi. Amplitude of 2. Good. This one is like an upside down cosine graph. So instead of starting at the top, it started at the bottom. And so the period of this graph would be 2 pi. And the amplitude, yep, is 5. Very good. Okay. So eventually we're going to get to the point where not only will we be able to graph the curves, but we will be able to take a curve that is already graphed, and we want to be able to write the equation for it. Okay, so this is kind of us getting started with being able to recognize some important parts of the graph. Okay. Your music might be paused or whatever, but I shouldn't see headphones. So headphones need to be all the way out. I know, but I just said I don't want to see them at all. Okay, we flip to the next page. So these are matching problems where we're going to match the amplitude and the period, and then displacement is what they say instead of vertical or horizontal shift, but it means the same thing, you moving it left, right, or up or down. So if we look at the answer choice A, this one is going to have an amplitude of 1 and a period of 2 pi divided by 3. So the 3 is in front of the x, so the period is 2 pi divided by 3. And what else has it done? Shifted to the right, pi 6. So can anyone see what number that is? It's not number 3. Is it number 2? It's not number 2.
12.
Now, if you look, there are too many answer choices. Do you guys see that? So some of the answer choices don't get used. So it might be one of the ones that's not used. Let's go ahead and try B and see if we can find that one. So B has an amplitude of 1.5. B has a period of 2 pi divided by 4, which is pi over 2, pi halves, so 2 over 4 becomes 1 half, pi halves, and it has moved to the right, pi 6. That one's number 3. Okay, so B is number 3. All right, so C has an amplitude of 2. It has a period of 2 pi divided by 2, which is just pi, and it shifts to the right pi fourths.
So this verse, how do you know it's just the right?
It shifts to the right because there's a minus, and inside the parentheses is the opposite of what we would think. So it's kind of like the transformations we've done in the past. The difference with the transformations is that we would have called an amplitude a vertical stretch or compression, and we would have called a period change a horizontal stretch or compression, and for this unit they gave them different names, but you still find them the same way. Okay. All right, does that go with one, or is that one of the ones that's not used? That's so annoying. Okay, so let's do the next one. Amplitude is 1. The period is 2 pi over 3. It shifts left pi.
That one's 5.
That one's 5, yep. So that's D. Okay, do we see how it works?
Yes.
Okay, so go ahead and keep working on that.